Hello friends, again welcome back to Indiamoon channel. I'm a Gaurav Tripathi. So that's the question come that why is these um, many data structure is required? Can't one enough to give the entire information to store the entire information? The answer is no. What is that? So let me we give me you example. So very example undo booking system application e-commerce and reports of student reports of employee and array. Okay, it's come about. So first we give you example. I hope everyone know undo operation that used to do our system. Okay, what is this? Undo operation is so keyboard is control plus Z and type while doing the undo operation. So usually what happens is that suppose we delete some content is now suppose we want to get this content again. So what will happen? I will just press control plus J. What every last information we have, okay, that will come out. It's last in first out. This is something of stake with that data structure that where developer can design the keyword they have implementing the stack based data structure while it basically store the last information that we are typing, right? Now we are saying example of stack data structure because inside the particular operation we want to implement LIFO of terminology. Okay, similarly, suppose we want to build a network. Suppose you want to book Ola cab or Uber. I using Uber. So what happened? In that I used to enter the destination. After enter destination, we click on the search button. It will try to look for the nearest cab, right? And according to that it will also give the changes also. So here what happening is that we booking some, we are making some thought of network on the basic of distance on the booking of petrol required giving the cheapest well. Okay, so you will see what happening that graph based data structure will hold into picture making birth first search BFS and depth first search DFS. So it is the BFS come in birth first search. Okay, this sorted distance, right? Okay, it's a real time application how basically the things are useful. So in this application to listen music, it's a Spotify. Suppose in Spotify I moving to next. So what happening is that I will able to get the next music. Okay, as we moving to previous, I am able to get the previous listen music, right? So here will be see in a way I dealing with 2 point. One is next and one is previous. Okay, and that is something application of is Spotify, and that is implementing lot of linked list. Now it can be W linked list. Why W linked list? It can be circle linked list. where the last particular music is connected to with the next first one. That's where circular linked list connected to pictures. Depending upon what kind of app you are using, this kind of data structure are useful. Okay, so in the next we see e-commerce application. What's my e-commerce website? You find out their product is called root node. Okay, we are having some category sub product, it's a internal node, and understand under that I able to get the final product which I want to order, it's called leaf node. We say this is leaf node. To get the final product which I want to order, it's a leaf node. And what's the root node? You find their product, each product is root node. And internal node, we are having some category sub product, it's called internal node. We say, imagine this is the application of tree based data structure. E-commerce application is a tree based data structure. Okay, employees reports or reports on student or reports or any related to organization, employee related to faculties of any college, university. Okay, you want to store the reports of employee or student or any organization reports. We store the must if student. Okay, first we understand we store the must of student, insertion and deletion. Now the particular student may frequent linked list. When we frequent linked list, when we are inserting and deleting data, when we need to search any employee in particular data, then is a very much frequent. So searching is very much frequent that time. So where you will say, okay, if the search is frequent, is more preferable, here we use array. So that array random is the concept of binary search. So basically if you will, the same problem also can be solved using different data structure depending upon what use case trying to solving upon, what kind of problem to solve and help of which you should serve about the kind of data structure we will be using. I hope you understand why so many data structures require. Every data structure has their different role, and in the next lecture we understand what is the algorithm and properties of algorithm with example. So please support my channel. Thank you very much friends.